Let's take a look at one last concept regarding equilibrium, which is Le Chatelier's principle. So essentially, Le Chatelier's principle is something that allows us to make predictions based on what changes are happening with a particular reaction or system. So sometimes we don't have the time or the information to be able to determine how a particular change is going to affect a system mathematically. So we can't go through all the calculations, okay? And we don't necessarily need all that detail as well sometimes. But if we change concentration, pressure, and temperature, we can shift the equilibrium of a reaction. And we'll look a little bit at what each of these will do and how it'll shift it. A catalyst does not. So a catalyst is something that is required in a reaction. It's used in a reaction, but it's not used up. It's required for the reaction to occur, but it's not going to change the equilibrium of the reaction, because a catalyst speeds up a reaction, but it speeds it up going forward and going backward equally. What that means is that if you add a catalyst, it's not going to change the equilibrium constant or equilibrium expression, but it is going to make it so you get to that equilibrium faster. So catalysts, we'll talk about we'll use this in these examples, but it's important to remember it doesn't change the value of your equilibrium or the ultimate final equilibrium. It just makes it so it's faster. So let's take a look at a few things. If we change the reactants, products, or catalysts, so things that are going to favor our reactants or shift the reaction to the reactants, so it's going to shift it to the left. Those are things like if you increase the amount of products or you remove the reactants. So remember, we have reactants, and we have products. If I dump some more product in here, it's going to shift my reaction backward to reach the ultimate equilibrium. If I remove reactants, so if I take some of these away, then I'm going to need the products to react backwards, become reactants to replace them. So you can think about this as kind of a little bit of a balance, a bit of a teeter-totter. We have the opposite thing happening for favoring your products, so going toward the right. If you increase or add reactants, or if you remove or decrease products, it's going to push the reaction to the right so that it can equalize that balance, so rebalance the reaction. Catalysts, like I said before, are not going to change that directionality. So it's not going to shift the direction of the reaction to the left or to the right. Let's look at how some more things affect our Le Chatelier's principle, or what happens in a system. We have pressure. If we increase pressure or decrease pressure, this is going to only affect gases. So if your reaction has no gases in it, pressure is not going to make a big difference. But if we increase pressure, we're going to favor the side with fewer moles of gas. So overall, fewer moles of gas. If you decrease the pressure, it'll favor the side with more moles of gas. You can think about if you're increasing the pressure, this is also like if you're decreasing the volume. So remember how pressure and volume are related. Essentially, you're squishing it. So if you're squishing something, the moles of gas, they take up a lot of space. So if you decrease that space, if you increase your pressure, you squish it down, it's going to favor the side that has less moles of gas because it's easier for it to fit into that smaller space. For temperature, increasing the temperature is going to favor the reactants in an exothermic reaction, but favor products in an endothermic reaction. So take a quick reminder of what that will look like from our energy chapter. The temperature changes will change the value of K, so that's important to remember. All the other ones will not change our K value. But it does also shift our reaction. So as a reminder, from our exothermic and endothermic reaction, exothermic reactions have a negative delta H. You have heat coming out of the reaction. So you can think about it as you have your reactants, you have your products, and you have heat being released. So you can kind of think about heat as being a product in an exothermic reaction. It's exo. For an endothermic reaction, you have reactants plus heat products. So what that means is if I heat up, or if I increase the heat, increase the temperature of an exothermic reaction, it's going to push the reaction away from the heat. It's going to push it toward reactants. If I increase the heat on an endothermic reaction, it's going to push it toward products because I've got the heat over here. So if I increase the heat. The opposite would happen if you decrease the heat or decrease the temperature. I'd like to try to apply Le Châtelier's principle to these three reactions. Which way is the reaction going to be shifted if you do these different changes to it? So if you increase the temperature of the reaction, what's going to happen in reaction A? What's going to happen with reaction B? What's going to happen with reaction C? Do the same thing with the other principles. See what's going to happen. You can take a moment to pause the video, try and do these yourself, and then take a look at the answers in just a moment. So here are the answers. So to check it against your answers that you got for those problems.